Hi everyone. Uh, this is day 4 of Alternative Code in x86 assembly. And yeah, day 4 are scratch cards. The gondola takes you up. Strangely though, the ground doesn't seem to be coming with you. You're not climbing a mountain. As the circle of snow islands recedes below you, an entire new landmass suddenly appears above you. The gondola carries you to the surface of the new island and lurches into the station. As you exit the gondola, the first thing you notice is that the air here is much warmer than it was on Snow Island. It's also quite humid. Is that where the water source is? Next thing you notice is an elf sitting on the floor across the station, and what seems to be a pile of colorful square cards. Oh hello, the elf excitedly runs over to you. How may I be of service? You ask about water sources. I'm not sure, I just operate the gondola lift. That does sound like something we'd have though. This is Island after all. I bet the gardener would know. He's on a different island though. The small kind surrounded by water, not the floating kind. Yes. We really need to come up with a better naming scheme. Tell you what, if you can help me with something quick, sorry. If you can help me with something quick, I'll let you borrow my boat and you can go visit the gardener. I got all these scratch cards as a gift, but I can't figure out what I've won. The elf leads you over to the pile of colorful cards. There you discover dozens of scratch cards, all of their opaque covering already scratched off. Picking one up, it looks like each card has two lists of numbers, separated by a vertical bar. A list of winning numbers, and then a list of numbers you have. You organize the information into a table, your puzzle input. As far as the elf has been able to figure out, you have to figure out which of the numbers you have appear in the list of winning numbers. The first match makes the card worth 1 point, and each match after the first doubles the point of that card. For example, card 1 has 5 winning numbers, 41, 48, 43, 83, 86, 17, and 8 numbers you have. Well, those. Of the numbers you have, 4 of them, 48, 83, 6, 31, 17, 9, in the wrong column, 17 and 86 are winning numbers. That means card 1 is worth 8 points, 1 for the first match, then double 3 times, yeah. So in this example, the scratch card's worth 13 pounds, take a seat in the large pile of colorful cards. How many points are they worth in total? Okay, so the thing is, this looks really easy. Like, especially compared to the last few days. This, like part 1 seems really easy. Like, what are you doing? You're skipping, like, the first part, reading a list of numbers and checking how many of those appear in there, and then taking, like, 2 to the power of that. Or actually, probably taking 2 to the power of that, like, in line, in one pass. So just doubling every time we find one. Actually, maybe not if we start at 0, that's a special case, but that's really easy. So I guess, I don't know, I'm just gonna try that. I don't know. Haven't really done much the last few days, so I guess that's a nice introduction for getting back into assembly. Yeah. Okay, so day 4. Let's copy our GUnit and let's get our template thingy. Well, it's not really a template, but our last one. Just so we have something, and gonna get the input. Okay. Right, so what are we gonna do? First of all, let's keep one of those. Oh, we're definitely gonna need read number. Number 2 gear, we don't need that one anymore. And we don't need our loop here. See, this one was so much harder. Okay, to be fair, I didn't really do day 3 the way it was intended. Like, you know, as a one pass argument was way harder than if you just used like a 2-dimensional array. I guess that makes sense. Yeah, let's keep that part. Oh, don't. Get rid of the entire selection. Yeah, okay. Keep that, and keep those, but we're not gonna keep any of those other than total sum. Yeah. And I guess we can keep color guard character. That's just kind of useful. Yeah, okay, so yeah, let's look at our input. So we have what? Something up until colon. We don't actually care about this number at all. Yeah, we don't care at all, we just care about the total sum, so we can just skip that. Then we have a list of numbers of how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Absolutely, yeah. Wait, 10, I can count. 5, 6, 7, 8, 9, 10. Right, we have 10 numbers, of course we do. And then we, yeah, I guess we can just like save those in a buffer and then go through those and check which ones line up. Okay, so that's really easy. That's like seriously super easy. I guess it's not like it's 10 times length of that comparisons, but that's fine. Like the small arrays, like sorting would be slower probably. So I guess let's just do that. So let's do our main loop. Okay, so what are we gonna do? First of all, we're gonna pass we're gonna pass up into the colon. So I guess let's do like a battle plan again, like we did last time. That was pretty useful. So let's do let's do it actually. Okay. So skip on press the first one. Let's say F, because I mean, if there's an end of file, that's the easy part, I guess. Actually, we should probably, that's fine. We can do it like that. So we're gonna skip until the first colon, then read 10 numbers into actually, what's kind of interesting is it really doesn't matter which one of these are the valid numbers and which ones are our numbers, or the winning numbers, which ones are our numbers, because we just need to compare them. We just need to like take the length of the intersection. So yeah, it actually really doesn't matter. Okay, right, so we are gonna remember the winning numbers because it's smaller, like a lower amount, so we can use a smaller array. Which actually really doesn't matter. No. Let's do 10 DQs. And I guess we just 10 numbers and put winning numbers. Let's count the number winning numbers present in winning numbers, and they go to the log winning numbers. Or actually add or put with sum. Okay, right. So let's start with this part. Okay, so skip one, or skip third number loop. Right. So we can read a character, and now if we hit a an end of file, we jump to menu F, which I guess is just this part. Actually not this part, but this, because we also need to print the number, obviously. Yeah, okay, so we print our sum and return. Yeah, or exit, actually. Yeah, okay, so if we hit an enter file, we're there, and otherwise if we hit a colon, we are skip card number loop done. Wait, and then that. And otherwise we just we just keep looping and skipping individual characters. Yeah. Okay. So far so easy. Alright, so we have skipped this part, so we need to read 10 numbers. Actually, we need to read one more space. Yeah, we need to read more space. Okay, and now let's let's use R15. No, actually we can't use R15. Let's use R14 for counter. Read numbers. Loop. Actually, we don't even need to. Actually, we don't even need to rely on the fact that there are 10. We can just read until the vertical bar here. So actually, it's way easier than that. Okay, never mind. Is it? Yeah, it is, because we can use our look ahead or single character look ahead. Yeah, okay, that works. Right, so actually don't count that one. Need one number. Oh, we still need to. Actually, no, we still need to remember the index though. Yeah, so yeah, I guess we just read 10. That's easier. Okay, so in order to read our winning numbers, yeah, we read, yeah, we just read a number. Okay, does that skip the last one or does it put it in? Is that still true? Yeah, that's still true. Yeah, it reads one past the last number, but that's fine. Yeah, so we're gonna read number, move result into it's called winning numbers plus 8 times R14. And wait, I guess we need to compare R14 with 10. Wait, 10. Hello, Swaka. Thanks for the raid. You're doing Edge of the Kitchen Sunny again. I can give you a shout out, right? That's what we'll do. Hi. Yeah. Good. Yeah. We're doing day 4 because yeah, I haven't really had much time in the last few days, but yeah, we can do day 4 now, and it's actually really easy. Like, I don't know if you've done this one yet. Yeah, but yeah, it's, I don't know, part 1 seems pretty easy, so we're just doing that one right now. Yeah, but yeah, I'm curious about part 2, I guess. I'm leaving along at this point. Oh. Okay, so yeah, we're just working. We're just reading, passing the input, reading those, and then just gonna check for those and those, and that should be part 1. Oh wait, I actually called it part 2. Should change that. Yeah. I don't know if you've done. Wait, I mean you probably have. But day 3 part 2 was really fun in assembly. Because you can do it in like one pass. Alrighty, see ya. Okay, right, so where were we? Right, we're reading our numbers. That should be everything there. Oh, it returns an RX. That's what you get for not using consistent calling convention. Okay, so winning numbers. Right, wait, okay, so we have read those. We need to skip. Just add it here. Oh no, it's not. We can do it here. Let's skip the characters. Next characters. And then just loop through those numbers and I guess count the number that matches up. And actually it's that one minus 1, 2 to the power of that one minus 1, I guess. But yeah, okay, that's fine. I guess we can just twice and then just guess that our compare own numbers. And we'll just do that until we hit a new line, I guess. Actually, does my... Actually, no, yeah, we can check after we read one number. Because, like, read number remembers the next character, just the new line in this case. So yeah, we can do that. Okay, so we'll read one character, we'll read a number. And then... Yeah, I guess if... RBX, it's our number. I guess we'll just look through our numbers array and see if anyone matches up. Okay. Let's do 160. Check in new numbers. And as long as RCX is... Or actually, if RCX is... Wait, oh, I actually didn't do the jump yet. If RCX is greater than or equal to 10, yeah. Jump out. So if... Yeah, someone here. If RCX is greater than or equal to 10, we can jump out. And otherwise, yeah, we'll just compare each one. Compare RBX to, what's that one, winning numbers, plus 8 times RCX. And if they're equal, if they're not equal, we can jump. But actually, we can jump back to loop, we can do... That's done, I guess. And if they are, because we need to check, we haven't hit a new line here. So, yeah, RX10. Actually, yeah, 10 is a new line, but if you write \n, doesn't interpret that as the / character and the n character. Let's not do that one. Yeah, okay, so g dot, wait, no, that one shouldn't. Whoops, I'm in the wrong loop. Yeah, I'm in the wrong loop, actually, we can just jump back out here. And if we haven't... Right, so if we haven't hit a number, we just continue, and if we have, then I guess we'll use... let's use a register, sure. Use R13. That's our count. Yeah, we can't actually do like the doubling thing where we just actually we can do that in line. Yeah, let's do it in line. So I guess can we? I don't know, that's kind of annoying. Let's just count the numbers of numbers. Yeah, let's count those and then do the power of 2 because it's easier. Okay, so I guess we just increment our 13 then, yeah, and jump back. Yeah, that's way easier. Okay, so we increment. Actually, if we did find one, then I think we can rely on there not being any duplicates. We can just jump out. Yeah, okay, and if we jump out, we can then compare IX to 10. So if we hit a new line, we're done, and yeah, I guess we just, where do we jump? We jump back into main loop, I think, yeah. We jump back into our loop. Yeah, and that's it. Oh, actually, no, that's not it. That's not it at all. We need to actually, yeah, we need to do the, like, actually compute our power of 2 and then add that to our total sum. But that's easy enough. Let's do, I don't know, move RBX. Actually, I guess if 13 is 0, let's about 0 points, we can just skip it and go back to our main loop. So I guess in that case, jump back into our main loop, and otherwise, let's do the annotation better. Yeah. And if it's not, right, so if we have found a number, then what? Decrement 13. Move. Let's use, oh no, let's use Ix, why not? Ix is 1, and then, that's 2 to the 13 minus 1. Right. Yeah. Ix is 1, what does loop do actually? I think loop would make this a bit easier, but I don't know. I think that's the 1 or 2 loop. And we jump back into that one if R13 is still larger than, oh actually no, we need to do that one initially. And then we can decrement first, I guess that makes things easier maybe. And then we multiply Ix by 2. Actually do we... Oh wait, I'm an idiot. I don't need to do a loop to compute powers of 2. I can just do shift. Jesus. Okay. So that's actually, yeah, let's decrement 13 and let's do left shift, right? Yeah. What's the what are you doing left shift in x86? Like there's like logical shifts and numeric shifts, right? SHL. Ah, that works. Yeah, it's an unsigned shift, I don't care, because it's unsigned numbers anyway. And yeah, so I guess it's which order? What's the order? So I guess it's Ix R13? Maybe? And now add that to our total sum. And jump back to our loop. Okay. Yeah, that should be it maybe even. Yeah, I think that's it. That was easy if that actually works. Let's let's just try that. I might have messed up the order here. I don't know if that's correct. Let's see. So let's try and run it. 1.3 milliseconds. That seems correct. Seems pretty realistic. Let's see if that's correct. There you go. And that's not the right answer. Okay, so I guess I probably messed up the order here. Let's try R13Ix. That's the exact same result. What? Wait, is left shift associative? No, it's not. No, it's not. Wait, why does that do this? Return the same thing? That's bad, I think. Let's try GDB. Oops. Oh, I actually can't do any of those other than total sum. What? So far. What? Oh, I'm in the wrong. I'm in the wrong day. That's why. That's why nothing changed also. Okay, let's part 1. Okay. I was kind of surprised that one compiled on the first try anyway. Okay, 180. That's not a thing. Okay, how does shift left
T'as un
work?
grand frère ou t'es tout seul comme moi?
En fait, j'ai un petit frère.
Ah, c'est mieux que rien. Comment il est?
Tu me fais beaucoup penser à lui, il était aussi gentil que toi.
Destination count. Yes, it's IXL13.
Tu paries qu'elle est loin d'ici.
En effet, elle est dans la galaxie.
Oh, does that not...
Il faisait bon y vivre.
Wait, do I need to do like...
Un jour, un savant spécialiste en magie noire créa un monstre.
No, what? Wait, can I do that on
Il détruisait tout sur son passage.
6 bits or something?
Des milliers de
Is that how it works?
ils n'étaient plus que des champs de
This is a... It's AL.
J'ai perdu toute ma famille.
No, that doesn't work. What? How do I shift left? Or can I only do... What?
Minorcia.
How does shifting left work? That complicated of an instruction, is it? This version 64-bit. Do I need to do like EX? No. I mean, it's also such a helpful error message here. Let's do those first, I guess. There was no operand for data declaration. Wait, how do you do bit shift? Ah, can't be that hard. Which is an arithmetic logical shift. Upward. But if I do like one, that works, right? Yeah. But oops. Oh, that's bad. Okay. Do it on like what? Oh, I guess maybe this one needs to be smaller. So I guess I can do like move that into RBX and then use like EBX or something? Or I guess just BL? No. But how do you do bit shift between registers? C6. Hard shift bit between two different registers. Oh no, that's not very thank you. Okay, if I do EAX, can I shift that one? No, can I shift that one by 2? I can. Can I shift that one by EBX? No. With BL. No. Oh, is SHL just with an immediate? Can you do SHL with a register? Or is AL as well? I'm a little confused. If I do auto left, that won't work. No. Why? Wait, okay. Yeah, instruction. Oh god. Oh, x86 opcode encoding is so complicated. Okay, I need to look something up here. HHX, what's the difference there? Oh, oops. Does that one make a difference? No. What am I supposed to do? Okay, I genuinely can't figure out how to do bit shifts. So, oh, actually, wait, I have one more idea. I guess I'm just gonna switch my screen so it's a bit more interesting. Wait, where is it? Let's look at the NASM documentation, but that's more interesting. Okay, so there's like a thing for instructions somewhere, right? Instructions on the Jesus, that's a lot. Yeah, search files. Instruction list. That's good. God, that's a lot. Okay, SHA. Right, selection can take, what does that mean? You register 64 to 64 CA. Or is it register, what? Why does that one take 3 arguments? Is that not what I think it does? It takes 2 64-bit registers and an immediate. So I guess if we do like that and 1, is that one? No. I'm so confused. I'm just trying to do bit shift. Can't be that hard. What does? So shift the operand to the destination left, the number of bits specified in the count operand. Bits shift beyond the destination, first shift into the CF flag, right? 0 fields, equivalent to multiply by 2 to the n. Yes, exactly, that's what I'm trying to do. To change to the register. I don't know, I guess that doesn't work, or do we do need to mix here? Okay, I guess I'm just not gonna do it then. That doesn't work, right? No. Okay, so I guess not. Let's not do left shift. I guess we'll just do a loop. There shouldn't be many, so it shouldn't be that much of a difference. Okay, so 2 loop. So I guess we'll just multiply rex by 2. Actually, I guess, is this one faster than shift? I have no idea. Yeah, so I guess we'll multiply rex by 2. Decrement by 13, and actually no, we can decrement afterwards, and then we can skip like that jump here. Take R13. Compare that one with 0 and not equal repeat. Okay, cool. Right, so that's how we do power of 2, and then we get IX out. That should work. 82. Oh, I'm That's not, doesn't back then I shift left? No. And it's running in infinite loop. That's great. Okay, so I guess what are we gonna break on? Oh no, let's break on. Let's just break on start and run for a bit, I guess. Yes. Okay, so yeah, we're here. I guess we'll just. Oops, what's happening? Oh. What? What's happening, GDB? What? Wait, why is it calling print number? What? Oh, I'm an idiot. I don't actually want that one here. But why does that one seem to kind of crash things? I'm what am I doing? Loop is jumping to itself. Yeah, okay. That explains a lot. Wow. That's okay. Still looking though. So I guess, yeah, let's just step through. And okay, there's no end of file, that's good. And it's just skipping until here. And then yeah, now it's reading a character, and that's a 32. That is that. Is that, yeah, that's a space. Yeah, right. Yeah, of course, it's space. So that's here. Oh, that one was. Wait, what am I comparing? Info option 0. Oh, I'm comparing R14, not IX. Yeah, right. That's just the loop. Yeah, it's not jumping there. It's reading a number, and that one is 15 in RBX. Yeah, 91. Why did I say 15? Yeah, so that one's 91, and then it's just selling that one. Can't do like skip until. No, can't do like. Until. No, I don't know. I think it's not. Wait, actually, let's display our winning numbers already. That's a, what is that? That's a long array. 10 longs. Yeah, so 91, 73, 57, yeah, seems correct. Good. Oh, I'm missing one. Oops, I'm missing one. Why am I missing one? 14 to 0. Wait, that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the change jumps out. Yeah, that's correct. Should be. Not sure if that one spot. Guess it's continue though, because it's not. Well, it's critical, but not the only issue, presumably. Presumably not what's causing an infinite loop. But where am I? Check in winning numbers. So what? I'm already here. Okay. That's the RBX is 0. 0? Shouldn't be 0. Let's okay. Wait. Let's just run from the beginning, I guess, and let's just, break on that and run done. Yeah, so that's our loop. And now it's 1 iteration, 2 iterations, 3 iterations, 4, 5, 6, 7, 8, 9. And 0. Isn't this number 0? Oh, no, that's an 8. Oh, because there's a leading space? Are you kidding me? Oh, that's annoying. Okay, actually, no, that's easy. That's easy to fix, but it's aligned with leading spaces, that's why. Okay. That's... Okay. And I need to do that in both of those. Okay. I guess let's just do a read number of leading spaces function then. Actually, we can do that in read number. We can just allow us leading spaces. Okay, so I guess we yeah, that's way easier. So I guess if it's just have a case here where y, what am I doing here? 48, that's a 0. Actually, we can use 0 here. If that's a 0, and if that's a 9. Yeah. Okay, so if Ix is what is a space, we just keep reading. Yeah. Does that help? No, it doesn't. But that should read the number correctly, hopefully. So that's with numbers done. Let's try that. And let's display. Let's actually put that in our GDB. As an array of 10 longs or it's following numbers. Yeah. That's yeah. Oh god. Wait, what? What's happening? What's wrong there? I think I broke read number. Okay, okay, so that's from one iteration. Oh my god. Okay. Okay, I guess we'll step into that one. What's happening? Sure. Oh, it's IBX and IX, that's why. No, it is IX. No, that's correct. Okay, so it's trying to skip that, but it doesn't do that, because why would it? Wait, what? X 30. What? What's happening? Let's enter that one. Just I know what it does. Reach out, change the character. If that's in space, we jump back into. Yeah, we just skip it. What? Okay. So what's happening? EVX is 0. That's correct. It's reading one character. That's 57. That's what? Actually, can I do? Not really do that. 57. That's a 9. Correct. Let's compare that with space, which shouldn't be equal. So yeah, it's also a valid number. So 9 multiplying IVX by that, which is 0. What? Wait, what? Oh no, it's multiplying IVX by 10, which is 0. Yeah, that's correct, right? And adding that, so we get 9. No, yeah, that's correct. Wait, is the number being read correctly? I think it is. Okay, so wait, let's read winning, no, start read winning numbers loop. on that, and let's see what's happening. Okay, so it's reading a number, and that one is completely off. Why is that one completely off? What? Oh, I know why. I'm an idiot. Actually, yeah, God, of course. Yeah, we can't. We also use the space to, like we can only skip initial reading, initial reading spaces. So I guess let's move the read char. Out that one, so we can like, put it at the end. Yeah, okay, and now we can do a reading spaces. Nope. If there's a character, if there's a leading space, we jump to skip leading spaces. Yeah. And that should hopefully work. Yeah, that works. Okay. So that one should read them correctly. Yeah, okay. I can check. I think it's still looking good, right? Yeah. Okay, so I guess let's see. Yes, we have read our numbers. Now what? We're skipping 2 characters. That's a space. Yes. Actually, we don't need that one anymore now. Yes, actually, that's yeah. Let's remove that one just to make it a bit simpler. Okay, so what we do? We count the matching numbers and right, and check each number, I guess. Well, I'm probably jumping to the wrong thing once, right? Yeah, I am absolutely jumping to the wrong one. That's fine. But does that break everything? Maybe. Maybe it does. I don't know. That's not the only thing. Okay. I guess. So we are reading a number that's that's 89. Yeah, that's good. And that one doesn't appear anywhere, so I guess we just jump through a bunch of numbers. Wait, are we incrementing? Right. Oh, we're not incrementing something, that's why. Oh, that one should increment something? Oh, increment CX under 13. Whoops. No, that one should increment 13, but yeah, either way we need to. Okay, we can do that. Okay, I guess actually no, so we found one. Oh right, that one was correct actually. So if we found one, we jump out and check for 13, and otherwise we increment CX and jump back into our loop. Okay, silly mistakes. And that's way better. Okay, that looks like it could be good. Also 800 microseconds, that's cool. It's so cool. Okay, let's close here. And that's not the right answer. It's too high. Huh, okay, interesting. Something's going wrong. We'll just debug the first line then. Actually, let's just check what the result is. Because it should be, what should it be? 1, 2, 8, 4. Whoops. 8, 16, 32, 64, 128, 256, 512. Okay, it should be every single one. 1024. That's twice as much. I guess I'm not decrementing somewhere. Oh, yeah, right. I need to decrement R13 once more, I think. Yeah, and then that's correct, I think. So let's try that. Maybe that was the only issue. Maybe. Oh, and it loops now. Yeah, that wasn't the issue. Okay, so let's, I guess, break on compare numbers loop done. No, yeah. Break on compare numbers loop done. Okay, that's better. And where are we? Okay, so we're here. So did we find anything? We should have. We found 10 numbers. Yeah, that's correct, because all of those were matching in the first one. It's actually 2 to the 10 minus 1, what we're trying to compute. Okay. So we're not jumping out. So Ix is 1. And we keep multiplying for everything in Ix. Wait, what's that? Wait. No, that's wrong. Why are we doing that? Need to compare first and then just do a regular loop. Yeah, so if that one is 0, less than or equal to 0, I guess. We'll jump out. And otherwise we multiply, decrement, and jump back. Yeah, that's a regular, boring for loop. And that's better, but still... Wait, wasn't that what we had earlier? I think that's the same one, yeah. So I guess it's computing that one incorrectly. Wait, do we need to decrement once more? Yeah, we do. Yeah, we do need to decrement once more, because that's already 1. Yeah, that's... wait, so that's 2 to the 0. So that's... Yeah, that's if R13 is 1. Yeah, right, because if it's 0, we skip that one, and otherwise... we do minus 1. And that's looking better. Yes, it should be twice. Is that exactly twice what we got? Yeah, it looks like it. Yeah, that makes sense, because it's just like 1 power of 2 more when it's not 0. And when it's 0, it just doesn't matter anyway. Yeah, yeah, that seems alright. Oh no, I wasn't showing my screen. Oh no. Yeah, okay. But yeah, that's the right answer. Yeah, and I wasn't showing the correct screen. I know. Yeah, okay, so I just did this R13 and fixed this loop. I know. And I'm so bad at using OBS. It's not that hard. Okay, but anyway, okay. Right, so that works. That's 1 star, and correctly switch my screen back, hopefully, this time. Yeah, that's better. Okay, part 2. Wow, that's a lot. Wait, let me just get some string. Stay hydrated, folks. Okay. Part 2. Just as you're about to report your findings to the elf, one of you realizes that the rules have actually been printed on the back of every card this whole time. There's no such thing as points. Instead, scratch cards only cause you to win more scratch cards, equal to the number of winning numbers you have. Specifically, you win copies of the scratch cards below the winning card, equal to the number of matches. What? So card 10 would have 5 matching numbers. You would win 1 copy of each card's 11, 12, 13, 14, and 15. What? Oh god, okay. That's gonna be fun. Copies of scratch cards are scored like normal scratch cards and have the same card number as the card they copied. Yeah. Good on you. Missed my line. So, same card number as the card they copied. So if you win a copy of card 10 and there's 5 matching numbers, it would then win a copy of the same cards the original card 10 won. That's 11, 12, 13, 14, 15. This process repeats until none of the copies cause you to win any more cards. Cards will never make you copy a card past the end of the table. Jesus Christ, okay. that's... Yeah, I mean, Part 1 was way too easy, of course, for Joe's to be harder. Card 1 is 4 matching numbers. We win 1 copy of each for the next 4 cards. Each of the next 4 cards. So 1, 2, 3, 4, 5. Okay. Original card 2 has 2 matching numbers, so we win 1 copy of each of cards 3 and 4. Oh, actually, no, that's not that bad. I think. Yeah, actually, no, I think that's not that bad. Not as bad as it sounds, anyway. Oh, I want to do that in constant memory. That's gonna be tricky. Yeah, but that's not that bad, I think. It's no matching numbers and it's no more cards. Okay. Once all of the originals and copies have been processed, you end up with 1 instance of card 1, 2 instances of card 2, 4 instances of card 3, 8 of card 4, 14 of card 5. In total, this example pile of scratch cards causes you to ultimately have 30 scratch cards. Process all the original and copy scratch cards until no more scratch cards are 1. Including the original set of scratch cards, how many total scratch cards you end up with? Okay, that's, oh god, I have to think about that. Actually, that feels like there should be like a binary number counting thingy with like powers of 2 and sometimes not powers of 2, but maybe not. Wait, actually, is that? No, that's not the thing. But wait, let me just draw something out, I guess. Okay, so god, that's difficult. Okay, so part 2. Right. So what do we have? So let's say, what do we have to remember? I guess we have up to 10 cards. So I think, like, the thing is I want to do this in constant memory. But I think that's doable, because we can do like a shifting window, right? So we have, what do we have? We have like, let's say we have card 1. That one has 10 winning numbers. Oh, let's not do 10, let's do that one has 2 winning numbers. Then, what we need to remember that the next 2 are 1, 1, and then everything after that is 0. Next, like 8 after that. So we can have up to 10, right? I think that's 10. Yeah. So we have 2 winning numbers. So those 2 are multiplied by the number of cards we have here. Right, so wait, actually, we start with a total of 0, right? And then we do card 1, which has 2 and 1, right? So we have 1 of those. So I guess we process that one, we win 2 of each next one. So yeah, so we have 2 winning numbers, so I guess we increment, we start at 0, find that we have 2 winning numbers, so we add 1 to both of those. Actually, we add our current number to both of those. Right, okay, and then we do card 2, and let's say we find 3 winning numbers. Now our total, alright, and we add what we found for, we add our card, so our current to our total, so that's 1, and we're gonna process those separately. Right, and then we get to card 2. Right, yeah, so that's the end of card 1, and we're gonna add those lazily to our total, I think. That's probably easier. Yeah, that's easier. Right, so we had card 2, and we find 3 winning, oh, actually we need to shift all of those. Yeah, so wait, no, so we are at card 2 now, so I guess let's put like a marker there. Here, so our current is now, yeah, right, so we shift all of those over by 1, and our current is now still 1, because there was 1 card in card 2, and now we find 3 winning ones, so we add our current to each of those. So like this one's 2 now, this one's 1, this one's 1. Yeah, and then we keep going. So let's say we have 1 winning number in card 3, then excuse me. Oh, actually we need to add this to our total, so we have 2 in our total, and then start pressing the next one, shift these over by 1, and yeah, we have 2, so we find 1 winning number, so this one's at 3 now, and our total is at 4, and then we keep going. Okay, that actually doesn't seem that bad. Yeah, that's not that bad. Okay, should probably redo our loop though. Okay, so Actually, yeah, let's just do a loop from scratch. That wasn't super complicated. Okay, so let's do with winning numbers and... Oh, actually, no. We wouldn't do that one. We only need to change everything after here, because we can reuse that logic. Yeah, so we have... So R13 is our number of one scratch cards, I guess. Yeah. So actually, yeah, that makes... Oh, actually, it's actually really useful now that we didn't do the power of 2 like inline by multiplying by 2 every time. That we just kept a counter, because now we can... yeah, no, it's way easier because we just already have a counter. We can just use that one. Yeah, okay, so I guess next counts. Yeah, and we start off... Actually, oh wait, I'm doing this wrong, because we need to start with 1 of each, not with 0. Yeah, but that's fine. That just means we start with 1, not 0. Okay, so that's 10 keywords that are 1 initially. Yeah, okay. Right, so we count those, and 13 is our number of scratch cards. Okay, so we have processed ours, and actually we need what's the current count? It's just the current that's initially 1. And so yeah, I guess once we're done, we like increment all of those and then add our total. I think, yeah. Actually, we can do our total immediately. That might be easier, yeah. Okay, so yeah, I guess we just add here and then wait, where do we shift and where do we do what? I guess we can shift here. I think that's fine. I guess it really doesn't matter that much. Does it? No, it does. Wait. So we add first and then we shift. Yeah. Okay. So that's current. Oh, what's it called? No, it's not called current. It's called current count. In each of the first R13. Not. Where do you add as R13? First R13 values in what's the thing called? Next scratch card counts. And then I guess shift over by 1 and switch. And then we jump back into our loop. Yeah, okay, cool. Right. That's actually not that much even. Wait, is that it? Or am I missing something? 'Cause that's actually really not that bad. Well, it seemed way harder. Okay, right, so I guess I can't each of the first. And actually it's put a comment there just to make it easier to follow. Okay, right, so we add this one to each of the first R13 and actually filling up with 1, because we always have at least 1 of each scratch card. Okay, so I guess we move like 0. And okay, so if we have hit R13, we can jump out. And otherwise, that's what we will add to what? To scratch card counts plus ix times 8. Current count, although we should move that into register. But yeah, we move move that one to a register and then add that one there, and I guess that's it actually. That's actually we could use those together. That's like really, yeah, we don't need two loops there. We can do this in one. Okay, so let's add a comment. Okay, so I guess we move into, yeah, let's move into ABX current count, that's fine. Actually, yeah, no, that works. Okay, so I guess ABX current count, and now if 13 is actually no, let's move into RCX. What's scratch card counts plus ix times 8. So let's actually calculate next current count. We'll do that one first. Actually, no, not ix, just the first one. And we'll move into px, rcx, and actually no, we can no, we'll do it like this. IDX RCX, and then add IDX 1 in case, no, actually, add IDX current count if our 13 is larger than 0. Larger than 0. Okay, yeah, right, so that one, x equals, what's that? So that's if our current count is larger than 0, then this one is scratch card counts 0 plus current count. Yes, it's just that. So that's what this CMove is doing. That shouldn't be a CMove either, it should be a CMove G. No, it's CMove G actually. Yeah, okay. So that's one less branch, I guess that's faster, slightly. Yeah, okay, cool. Right. That's that. And instead of doing two separate loops, we are only gonna do one loop. And so move x0. And I guess we can shift over and add 1 if it's less. Yeah. Okay. Shift increment loop. I guess it's not really incrementing even. But shift add loop. Oops, and that should be add with a current count, obviously. And now what? Now x contains one new current count. We can write it back until we have shifted over. Okay. Yeah. So actually, I think we can just need our current count anyway. Actually, yeah. Let's do it differently. So RBX, it's our count. This iteration. Already move over the next current count. Okay. Okay, so we can just use RBX as our current count. Okay, so shift add loop. So what we're gonna do, we are gonna compare if ix is larger or equal to 10, we can just jump out anyway. Okay. And otherwise, then what? I think if it's yeah, actually, if ix is, wait, we are counting the lower one, right? If we have like, let's see, then we are counting this one and trying to shift this one over if and possibly add to it if ix is less than thing. Okay, so we shift over first. Yeah, so we move what's it called? Next scratch card counts. Plus ix times 8 plus 1. I don't think that's plus 8 actually. I don't think that's possible. Let's give it a second. I guess we'll move that one to register. It's 3 RCX. Remove dx. This one, and actually no, we'll move that one into this, and actually can, yeah, no, we can now compare if ix is less than 13, and actually if it's greater or equal, greater or equal, yeah, no, wait, we are 0 based, right, and so R13, that's 1, then should, wait, if that's 1, if x is 1, then we only we'll move y over without incrementing, right, so it's greater or equal? If ix is greater or equal to R13, we jump out, okay. Oh, we skip the addition. And if it's not, then we just do what we actually we need to increment ix here at the end. Okay, so and ix by what? By rbx, which is current count. And you, I think we could do that for a conditional move, but that's fine. Actually, yeah, let's do that for a conditional move. Because that's faster, I guess. Yeah, so let's move rdx rtx and rdx. Yeah, let's add rdx and let's add rdx, and if this one is greater than or equal, we're not gonna jump anywhere, we are gonna cmove ge rcx rdx. Yeah, and then move that one back, so this one means because that's very hard to read afterwards. So if actually no, if this one is less than 13, only increment or moved over count if it is if its index is less than 13, right? Yeah, okay, so that's what we're doing here, and then we'll move it over actually and increment ix. Wait, increment ix? No, increment ix and jump back into the loop. Okay, and that's what we're doing here. So we shifted everything over and we've done that. I think that's would be okay. Oh. Probably gonna do compilation error somewhere? No, just 0. Okay. Oh, right, because we need to let's add I guess we can already do that here. Add total sum rdx. That's way too many. What's that? Yeah, no, that's doesn't even fit into in a 32-bit integer. It's way too many. Okay, so let's debug things. Yeah, let's display winning numbers and also display our window. Scratch card counts. And let's display That can't. That's its useful. Okay. So are we gonna break? I guess let's just break after this part. So that's compare all number loops done. Oh, okay, so winning numbers seem correct, and next which counts are 1. Oh, and oh, I know what's happening. We need to. Actually, I'm not sure if that's what's happening, but we also need to move. Oh, this works actually. That's interesting. That one plus 9 times 8? Okay, yeah. The last one needs to be a 1. Okay, does that fix anything? Probably not. Well. Yeah? Not really. That's slightly small, I think. Okay, so we are here, and next switch gets a 0. And we first want to remove the total. Okay, where are we? Okay, so what's R13? R13 should be 10, right? Yeah. Okay, let's keep going. So, wait, actually, what's RC? What's current count is 2, because it's the next one, yeah. Next one's 2, that seems good. And that's gonna increment each one by 1. Or not. Oh no, it does. Yeah, 2, 2, 2, 2, 2, 2, 2. And the last one should be a 1. And yeah, and we're in the next one already. Because in the next iteration, total sum is 1. Yeah, because we've only counted the first one so far. And actually, no, wait, that's no, that's no. I guess we need to start at 1 and then add that. Yeah, I think that's how we need to do that. So we need to start our total sum at 1 and then add the next one every time. I think, yeah, last time that should be 0. Yeah, I think that works. Okay. Yeah, that should work. Okay, so current count. Well, that would make the result smaller, and it's way too large right now. Actually, it should just. Well, it's just a difference of 1, so it doesn't make much of a difference. That's not what I want to do. Okay. Where was I? Right. Okay. Wait, 4? Oh god, I missed something. I think that seems alright. Yeah. Yeah, the total sum seems fine. Oh, current count's very large. It's exploding a bit too much, maybe. Like, that's not the result, right? Can't be. Yeah, way too high. Okay. Why is that? I'm miscounting something somewhere, I think. Like, this probably off by 1 when I'm incrementing 1 too many or something. Yeah. don't know. Where would that be? Okay, so let's actually let's just use our own input and make that a bit easier, I guess. We'll use like let's get 1, 2, 3, 4, 5, 6, 7, 9, 0. Actually no, let's do 10. That way we can just count how many we have. But which language do you program in? Usually mostly Haskell and OCaml, but right now x86 assembly. Also some Rust sometimes, but not as much as I'd like to. Yeah. Okay. Right. Okay. So let's say we have. Actually, that's so annoying to test manually. Yeah, but let's do. Wait. Copy you. And just implement those just to make that easier. And let's say we find 2 numbers in our first one, and then we find 1 in our second one. Right? Let's see where that's gonna go. It's gonna be 14, right? Is that correct? So card 1, so that's 1. Then we have 2 of card 2, so we have 3. Let's put that down. 1, 2. So we have 2 of those, and then we have wait. So we have 2 of those, and we have 2 of 3, and then for card 2, we're doing 2 of those, and so wait, each one of those gets 1, so that should set 3 to 4. And now 3 doesn't find any, so 4 is at 1, 5 is at 1, and 6 at 1. Actually, I should probably add zeros here, I'm not sure. Can handle that. Oh, and now it's running an infinite loop. Oh, yeah, right. Yeah, because that's not valid input. 14. Yeah, is that 14? That's 4, 8, 10. That should be 10. That's too high. Okay. Right, so we have something to debug now, that's good. What exactly do you use Haskell and OCaml for? Compilers mostly, but yeah, you can do anything you want in Haskell if you want. I've written some web servers in Haskell, that's perfectly fine. Okay, right. So let's break on. Where are we gonna break? I guess compare them on numbers loop run, yeah. Okay, right, so after the first one, our sum should be 1. Because we have just this number. Oh, actually yeah, that's correct, I think. Right, and our next critical counts are 1 for everyone. Right. I guess we should also break on shift add loop done. That gives us a nice thing. Oh, why is it 0? Why are you 0? Oh, because that's oh no, that should only go up to 9. I'm just getting lucky and getting a 0 there. Oh no, does that break anything? I have no idea. I don't think it does. Okay, so total sum is 2? Wait, we're here. Okay. Where's total sum 2? I found 1 and we are already adding the next one. Yeah. Yeah, the one for card 2. Of which there's 1. Yeah. Oh god, I'm interleaving way too much here. It's making things slightly complicated. And oh wait, that's too many. That shouldn't be 2, 2. That should be 2, 2, 1. Oh, so it's not. Oh, so it's oh yeah, because that should be an LE, I think. No, it shouldn't be an LE. Wait, if our lower index is like the one we're moving into. Yeah, actually that's I guess, decrement ix, increment ix, I think that might be better. 10, yeah, that works. Okay, perfect. Actually, that might just be the answer, if we're lucky. Wait, let me keep that, because this one's kind of useful. Oops. Where's my input? There you go. Okay, let's try that. And that's that's so much better. That seems a bit low almost. But let's try it, I guess. Sorry. Okay, let's try that. And it's way too low. Yeah. Why is that too low now? Like the example seems fine, right? Yeah, like this one is fine. So let's debug that one, I guess. Let's compare our numbers. Yeah. Done, and yeah, what it's called. Shift add loop. Okay, so we are here, and okay, initial one. Yeah, so we have read all of them, so our 13 is correct, but those are our previous counts. Right, so we calculate that true. That one is an RBX. Yeah, that's 2. That's correct. RCX is 1. No, wait, RCX is 2. Why is RCX 2? Wait, isn't RCX the current count? Oh no, RCX is the next one, right? RBX is the current one, and RBX is 1, yeah. Okay, that's correct. So I guess we do what? Move. Wait, so, wait. RBX is correct. RBX is 1. And the next one, current count is 2, yeah. Now we are including this. Let's skip that one. And what's wrong? What? Okay, let's rerun that. Because after this one's done, yeah, that's wrong. This one should have been incremented. Why are you not being incremented? Oh, because I messed something up. Did that break something but also fix something somewhere else and like the mistakes cancelled out? Oh, I guess. I guess my CMove logic here is probably wrong somewhere. Wait, so wait, where are we? Yeah, why are you not doing what you're supposed to? Okay, so compare number done. Right, so we are our total increment our total sum, and we have set up all the registers and stuff, and now we can go into our loop. Right, and that one's gonna go from 0 to 9 inclusive. No, exclusive, which is correct, yeah, that's the length minus 1. And then what? Let's move RCX our old one, that's 1. Conditionally. Oh wait, why is RAX -1? Oh, because I'm increment. Oh wait, is that? No, let's compare. Compare probably just. That's right, yeah. Compare does like unsigned comparison, right? It probably does. So I guess let's not do that. Let's the increment R13 and decrement that. I think that's the effect. Actually, don't need to do that on everyone. You can just increment R13 first. I think that should work. That 25 way too high, but might still be correct. Like this part might still be correct. No, that's completely wrong. What? What? Okay, so if I don't actually that's actually no, I'm just confused. No, because if it's 0, it's gonna be -1. No, that's not. Okay, let's think about this. Okay, so R13 is the number of cards we have found, right? So in this case that's 2. Right, so we loop through our array and we shift everything over by 1, right? So we and what's that one supposed to be? Right, that one should be 2 2, but we shift everything over by 1, so it's actually 2 1 1 1 1. Right? Yeah, because we already did the first one manually. And that means what? So index 1 is less than 2. Yeah, so as long as the index is less than, like the new index is less than our count. Oh wait, but it's also 0 based. So wait, so that's index 0 and the runs less than 1. Yeah, so we need to decrement the count by 1. But that's gonna be weird with negatives. Is there a sign comparison? Probably is, right? Sign subtraction. Oh no, it is signed. Okay. I guess it works. Okay, cool. That makes things easier. So I guess yeah, we'll decrement 13 before we do our loop. And then that's 11. But that's better. That's much better. I think that's just an off by 1 because of the like the initial one and the way we're counting scratch cards, I think. Oh, shit. That's 1 and then flip everything over, which is kind of hard to see. Yeah, and that's working, I think. Yeah, 2 1 1 1s. That's good. Our total sum is 2 because we have count. Wait, why is our total sum 2? No, it shouldn't be 2. In any case, it really shouldn't be 2. If anything, it could be. Yeah, what could it be? It could be 1 or it could be 3. It couldn't be 2. Yeah, so I think the issue is just that we are counting. Yeah, we are counting the current number, right? This iteration, yeah. Okay, so yeah, we need to set it 0. And that's correct for this input. Let's try the actual input. That's looking better. And let's see if that's correct. There we go. And that is correct. Sorry. Yes, that's correct. Okay, awesome. Right, day 4 wasn't that bad, was it? Yeah, nice. Okay. Yeah, I think I'm gonna end the stream there. I'm not sure if I'm gonna have much time to stream again this week, but yeah, day 5 seemed to be pretty difficult apparently. Do you have What if Day 1? Yes, I do. Wait, I can actually give you the link. It's on YouTube, so yeah, because I wasn't entirely sure. Like, the thing is still, not entirely sure about like copyright things on Twitch, so I'd like with the music, so I'd rather put it on YouTube. That's safer. There you go. Okay. Here you go. Okay, awesome. Yeah, I found someone to raid. We're streaming Sim Griffin. Sure, let's raid you again. And let's oops, okay. Okay, yeah, so it was a fun stream. Day 4 was pretty
None of our tests are
pretty easy.
We scroll up, we see
Comparatively,
deleting
at least.
user, we don't see deleting users.
And so yeah, I'll see you next time.
Yeah.
And
So that first hook is actually running. That's actually the name we're looking
bye everyone.
for. Oh, and we can't search this very